Hi dear students. So today we will discuss the chapter 12 electricity. So already you are familiar with the term electricity. You know that suppose if the electric current or electricity is not there, suppose one day all the electric equipments, suppose the electricity is not here in this world, and you know that the difficulty, what are the types of difficulty that we will face, isn't it? Because most of our daily life things are happening or going on with the help of or on the basis of this electricity and the equipments, the electric equipments. So in this chapter we will discuss about the current, then Ohm's law, then the heating effect of the current and some other applications. Okay. So you should know what is current, isn't it? So we have already heard about the charge, the term charge. Otherwise we can say the static charge. So that means the charge is not moving. So the current means whenever the charge is moving, that is considered as the current, isn't it? The current of water, the current of air, that means the movement. The current is itself representing the movement. So the movement of the charge is known as electric current. Okay. So the charge means how can you define the charge? I think you may have already studied that one. Okay. The unit of charge, it is coulomb, and 1 coulomb in terms of electric charge, it is the number of electrons. Suppose if we are considering the number of electrons, the 6 into 10 to the power 8, 6 into 10 to the power 18 electrons should be needed for 1 coulomb charge, isn't it? So we have already discussed that the movement of the charge, it is known as current. More specifically, if you are saying the amount of charge passed through a unit area, a particular area in unit time, it is known as the current. Okay, the amount of charge passed through a area per unit time. The charge that we can define or represented as Q, isn't it? The charge is Q, and if the time taken by the charge Q to move a particular cross sectional area, if it is T, then the current I will be is equal to Q divided by T. Q divided by T. I is equal to Q divided by T. Okay. So I think you have already gone through that PDF that I have sent you. The expression of the electric current is one of the important thing, and moreover that the entire chapter is important. So you just give some more care in this chapter. Okay. As well, when you are studying, you just focus little bit more focus should be needed for this chapter. Actually, the concepts are very easy. If you are understanding the concept and studying, then it will be very easy. This chapter is very easy. Okay. So the expression of electric current, the amount of charge flowing through a particular area in unit time, or the rate of flow of charge. What it is? Rate of flow of charge. Rate in the sense per unit time. Okay. So in one word, you can define the current as the rate of flow of charge through a particular area. It is known as the current. Okay. As well, suppose if you are considering a conductor, you know that in the conductor the charge carriers are electrons, isn't it? The electrons are the charge carriers in the conductor. Conductor means the materials which will allow the passage of electricity. Okay, that are known as electric or electrical conductors. Okay. So in these conductors the charge is flowing due to the motion of electron, but the current is flowing in the opposite direction of the flow of electron. You have to remember that one. Okay, that means suppose if you are considering a conductor, okay, conductor, and the electrons are moving leftwards, suppose. Okay, so that means okay, the flow will be there if you are connecting a cell with the conductor. Okay, so the electrons are moving from negative to positive, and as we have studied it now, that the current will be in the opposite direction of the flow of electron. Okay, that is the positive ion. The positive charge, isn't it? It's holes. Actually, it is not there in your textbook. So this will be the direction of current. Okay, electron will be flow from negative to positive, and the current will flow from positive to negative in the conductor. Okay, that is in the opposite direction of the flow of electron, that you have to remember. Okay, now that means the positive charges in the direction of the current is in the direction of the positive charge, isn't it? That is means opposite to the direction of the negative charge. The negative charge here it is electron, and the positive charge here that will be considered as the holes. Okay, and now let us come to the next page. I is equal to Q by T, that we have already derived. Okay, now let us come to the unit of current. The unit of current. Actually, the unit of current, you can see for the charge Q, the unit is coulomb, and T it is second. So coulomb per second is the unit of current, or else it is also known as ampere. A-M-P-E-R-E, ampere. Okay, so you have to remember this one. And the definition of the ampere, 1 ampere, it is also given in that PDF. Define 1 ampere. This 1 ampere is constituted by the flow of 1 coulomb charge per 1 second, isn't it? If the charge value it is 1 coulomb and the time taken if it is 1 second, then the current value will be is equal to 1 ampere. So 1 ampere will be the charge flow, the 1 coulomb charge flow, if that means the current flowing through a particular conductor, if the 1 coulomb charge is flowing through that conductor. 1 coulomb charge per second, that is the 1 ampere. 1 coulomb per 1 second, it is which will be is equal to 1 ampere, that you have to remember. And some other units of the ampere, that one is milliampere. Milliampere, that is it will be represented as milliampere, and that will be is equal to 10 to the power minus 3 amperes, and as well microamperes, that will be is equal to 10 to the power minus 6 amperes. Okay, so 1 coulomb charge per 1 second, it is the 1 ampere current. That is the definition of 1 ampere, or else ampere. Okay, and milliampere and microamperes. Milliampere it is 10 to the power minus 3 ampere, and microampere it is 10 to the power minus 6 ampere. That things that you have to remember. And come to one example. One example it is given. Example number 12.1. A current of 0.5 ampere is drawn by a filament of an electric bulb for 10 minutes. Find the amount of electric charge that flows through the circuit. Okay, so we have to find out the value of Q. I and T values are given. I is in ampere and time T is in minutes. Actually, that minutes that you have to convert into seconds, that is SI unit. Okay. So as we know, I is equal to Q divided by T. So Q will be is equal to I into T, where I is equal to 0.5 and T is equal to 10 into 60. Okay. So the answer will be is equal to 600 into 0.5, that is half of 600, that is 300 coulomb. Okay, 300 coulomb. Likewise, questions may be asked in the examinations, so simple questions directly that you have to, the values that you have to substitute in the equation. Okay. So regarding these things, now let us come to the electric potential. Simply as a roughly we will, and before that, what is electric circuit? What is electric circuit? Actually, the electric circuit is the closed loop through which the current is flowing. For the flow of current, a path should be needed, isn't it? So the closed path through which the current is flowing, it is known as the electric circuit, which contain the resistors, capacitors, cells, then what rheostat, all those things will be there. That are the electric equipments. Okay. The function of those things that we will discuss, and the symbol that you have to study here in this chapter, that we will discuss when it comes. Okay. And now let us come to the potential. Potential. What is potential and what is the necessity of potential? Before that, let us consider the water. Suppose 2 beakers water you are having, and from the bottom it is connected. Okay, and the size of the beakers are equal. Okay, the size and the dimension of the beakers are equal, and in both the beakers same height of water it is there. So you can see the pressure over here will be is equal to the pressure over on the beaker 2, that is B1 and B2. So there will be no flow of water through the pipe. Am I right? It's equilibrium state it is actually. Suppose with the help of a piston, suppose if we are applying some pressure over here, okay, suppose if we are applying some pressure over here, then what will happen? The water will start flowing from B1 to B2, and the level of water in the beaker B2 will increase. Am I right? The same way in the case of a conductor, okay, in the case of a conductor, the potential, okay, the height of the water, we can compare that one with the potential. The potential on both sides will be equal. Okay, in the case of that is equipotential surfaces, it will be known as equipotential surfaces, because the charge is uniformly arranged. So the potential variation or potential difference between the two ends will be equal. So there will be no flow of charge will happen. Okay, there will be no flow of water as well. There will be no flow of charge over here. So for that you have to apply some external pressure. Okay, that external pressure will be, in this case of conductor, that you are achieving that external pressure with the help of a battery. Okay, okay, and that is known as the potential. Okay, the external pressure that you are applying to or for the flow of current or flow of charge through the conductor, which is known as the potential. Okay. For that we are using the cells or the batteries, and the V potential is represented as V, and that can be obtained by equation W, work done divided by the charge. In detail that we will discuss in the next class. Now just understand that one, that is the external pressure that we are applying for the flow of charge through a conductor, that is known as the potential, and for that the device cells or the batteries that we are using. Okay, thank you, and study well, and do write that notes, the PDF that I have sent you, study that one. Okay, okay, and write that example question also in the notebook. Okay, thank you.